So the displacement equation for the wave traveling along positive x direction is this, and for negative x direction is the second one. So according to the principle of superposition, the displacement equations get added, and using trigonometric identities we get the resultant wave or resultant displacement. Resultant displacement is twice a sine kx or cos omega t. So in this expression, amplitude of the resultant wave, the amplitude of the resultant wave is twice a sine kx. That is, a is equal to, amplitude is equal to twice a sine kx. Okay, sine kx. Now the amplitude of the wave depends upon the displacement along x-axis or value of x. When x is equal to 0, sine 0 is equal to 0, therefore amplitude is equal to 0. And when x get maximum value, then sine has maximum value 1, then the amplitude will be maximum. When a value of kx equal to pi, at sine pi, that is 180 degree, value of sine pi is also equal to 0. So at both the condition, when x equal to 0 or kx equal to 0, sine 0 is equal to 0, amplitude will be 0, and when kx value is equal to pi, sine pi is also equal to 0. At this time also amplitude is equal to 0. So we can generalize this as kx is equal to n pi, having value of n is equal to 0, 1, 2, 3, like this. Therefore x is equal to n pi by k. Okay, it is wave number. So we know wave number is equal to twice pi by lambda. Therefore x is equal to n lambda by 2, having value n equals 0, 1, 2, 3. So when n equals 0, 1 equal n equal 1, 2, 3, like, so we get x equal to 0, x equal to 0. And since x is equal to 0 means what? X equal to 0 means sine is equal to 0, sine of any angle is equal to 0, and we have amplitude is equal to 0. Also, the point at which, the point or the position of the medium at which amplitude of the wave is 0 is called nodes. Okay, the position at which the amplitude of the particle, amplitude of the wave is 0, we call that position or is called node. At node there is no motion at all. There is no motion of the particle at all. We will generalize this as kx is equal to n plus half pi. N plus half pi gives us what? All the values of pi by 2. That is, when n is equal to 0, it gives us pi by 2. When n equal to 1, it gives us 3 by 2 pi, or 3 pi by 2. When n equal to 2, it gives us 5 pi by 2, like that. Okay, in all these values of pi by 2, every time sine got maximum value. Okay, so x, from here x can be find out by putting value of wave number like this in this type of equation. We get n plus half lambda by 2, n plus half lambda by 2, where n is equal to 0, 1, 2, 3, so on. Okay, so in with these values of x, or with these values of kx, we always get amplitude of the wave not equal to 0. That means we always get value of amplitude. So a is equal to twice a. So a is equal to twice a, amplitude is equal to twice a, and at the position at which we get amplitude value, the position at which we get the value of amplitude, we called it as antinodes. Where amplitude is 0, we call that position as nodes, and the position at which amplitude is not equal to 0, it has some value or maximum value, we called it as antinodes. Okay, so in wave pattern we can draw both the nodes and antinodes. So let us draw the wave. So this type of resultant wave we obtain from the superposition of two different waves traveling at two different directions. Okay, so here these are the positions of antinodes. This is node, this is antinode, and there are two nodes at two different boundaries. Yet here amplitude is always 0. So two nodes at two boundaries and one node at the center. Number of nodes and number of antinodes depend upon the value of small letter n we are using here. So higher the number of small n, and that means n value, number of this type of ellipse or oval shaped waves we can find out at two different boundaries, between two different boundaries. Okay, so this is called for second harmonic, and if there is only one loop, then we will say it as fundamental or first harmonic. First harmonic is obtained by putting value n equal to 1. This is a second harmonic by applying value n equal to 2, and by application of n equal to 3 we will get 3 harmonics, and similarly higher the number value of a small letter n, higher the number of harmonics. So if the length of the string is L, that means this is a string. So, if the length of the string is L, then we get x equal to 0, and at x equal to 0 and x equal to L we get two nodes. Okay, these are the nodes condition. And at L is equal x is equal to L by 2, at x is equal to we get another node. So these type of waves are called stationary waves. So the possible wavelength of these stationary waves are fixed by the relation wavelength is equal to n lambda by 2. The wavelength of the stationary wave, the wavelength of the stationary wave is fixed by the length of the string, and wavelength relation is equal to twice L by N. And frequency of the stationary wave is equal to N V, speed of the wave, divided by twice L.